All right, this is the buffer solution lab, and we're going to create a buffer from the acetic acid. There's 50 mils of acetic acid in here right now, and then we're going to add in sodium hydroxide to create some acetate. So that'll be a buffer here. Then we have in this beaker 50 mils of ammonia, and we're going to add in HCl until we create a certain amount of ammonium ion, but we'll still have some ammonia, so that'll be a buffer. And then we have, these are just pure water, distilled water in each, 50 mils in each. And what we want to do is check how the pH changes with the addition of an acid or a base to these buffers compared to pure water. We should see a much greater change in pH for these. So we're going to be creating our buffer next for each of these, and then we're going to be testing all four of them against the addition of acids and bases. Okay, here is the titration of ammonia with HCl. What we're trying to do is get the pH down from 10.36 down to between 8.9 and 9.1. That's would be what we'd like. And so I'm going to start adding this in. So the HCl is in the burette. Oops, didn't mean to put that much in, but that's fine. See if I can turn this so you can see there it is. Whoops, man, there's not a lot of play in this. Okay, there we go. Okay, we're closing in now. I was going to try to get it at exactly 9. It's not necessary because we're definitely in the range, but I'm going to, since I seem to have a pretty good control over this, drop by drop, so we'll go till we hit right at 9 if possible. There we go. Okay. And here's the amount of HCl added to the ammonia to make the pH 9. Okay, so I'm going to add in into pure water. So it's a little acidic because all water samples that sit out for any length of time are going to be acidic because they absorb CO2. They create carbonic acid. Now, I've got to be really careful here. I'm going to just be adding 1 drop at a time because it's not going to take much to drop the pH of pure water, and that's the point of this lab, to show that buffers can withstand changes in pH a lot better than pure water. So I put in about, it's like 5 drops. You can see that it is dropping quickly. And this one, sometimes it's really hard to hit. What do we want? Between 2.3 and 2.5. Okay. Okay, so we're going to stop in 2.42. And then we're going to try to get the buffer to match that as close as we can. So let's see what the volume was. So here's the volume of HCl that was added to pure water to get it down to I think it was 2.43. Whoops. Now here's our buffer that's at 9. Oops. pH 9, and I'm going to start adding in the HCl and see how much we have to add to get it to drop to what it was before, about 2.4 pH for the pure water. You can see that I'm not too worried about adding it in quickly because it's going to take quite a bit. Gotta turn this up. So instead of drop by drop, I'm letting it go in. Don't go to don't get too overconfident here. But the buffer really helps protect that pH. I'm going to go to just drop by drop now. Okay, we'll speed it up a little bit. I don't have to get it exactly the same as it was, but I'm going to try to get as close to it as I can. Oop. And right there. And here's the volume that was added to the buffer to get it to drop to the pH of 2.4, 2.43, just like the pure water. You can see that we had to add quite a bit more.